So in yesterday's video for 2.3, we introduced linear functions and we pretty much exclusively focused on slope-intercept form, or y equals mx plus b. In today's video, we're going to go over the two kind of lesser common linear functions or forms of them, which is going to be point slope and standard form. So first we'll start with point slope form. Point slope form is y minus y1 equals your slope times x minus x1. Everything that you see in red is what you would plug into your equation. So looking at an example for number 1, they want you to write an equation of a line that passes through negative 5, 2 with a slope of 3 over 5. Now we want to use point slope form here because they gave you a point and a slope. Therefore, your easiest way to make an equation is to put this in point slope form. How you're going to do that is by plugging everything in from where they gave it to you. So for my coordinate, this is going to be my x1 value, this will be my y1, and I'll just go from here. So I'll do y minus 2 equals, my slope here is 3 over 5, times x minus negative 5, so that's going to change to positive. And I'm done. Number 2 adds just one small step in the beginning here. Now, instead of just giving me the slope straight out of how in the last problem they gave me 3 over 5, now they just give me 2 points. So they say a line passes through 3, 2, and 5, 8. And again, they want to know what the equation of this line is in point slope form. So the only extra step that I would add in a problem like this is I'm going to manually find my slope. So remembering from yesterday, your slope is the change in your y values over the change in your x values. So in this problem specifically, I would do 8 minus 2 over 5 minus 3, which shows me that my slope here is 3. Now from here, you have two coordinates to pick from. You could pick either 3, 2 or 5, 8. It doesn't matter. I'm just going to go with 5, 8 here. Again, this will be my x1 and y1. Plug it in and I'll be done. So I'll do y minus 8 equals 3 times x minus 5. The next problem or form we're going to talk about is standard form. Standard form is ax plus by equals c. This is probably the least popular or common linear form that you'll be working with in this unit. The main thing to remember from it is that it just kind of has the x and y's together and then the constant number by itself. So we'll just look at one example problem of something that you might see along these lines in this chapter. This question asks, what is an equation of the line y equals 3 over 4x minus 5 in standard form? So right now I can see that this is in slope-intercept form. To change it to standard form, I'm just going to bring the x over. So all I'm going to do is subtract that term 3 over 4x. Those will cancel out. And I'll be left with negative 3 over 4x plus y equals negative 5. The last thing that we're going to talk about today is parallel and perpendicular lines. So the two things that you want to remember here is if two lines are parallel, then that means that their slopes are equal. So again, remember, parallel means same slope. On the other hand, if two lines are perpendicular, that means that their lines meet at a right angle, and that means that their slopes are going to be negative reciprocals of one another. So in other words, you would take that slope, you would flip it, and change the sign. So to finish up this video, we're going to look at two example problems that kind of combine all the stuff that we've talked about today. In problem number 6, they ask, what is the equation of each line in slope-intercept form? In part A, they're saying the line parallel to y equals 6x minus 2, going through the coordinate 1, negative 3. So how you're going to want to go about these problems is in 3 steps. First, you're going to want to find your new slope. So that's when you're going to really pay attention to the fact of, okay, is my line parallel or is it perpendicular? Next, after you have your slope and your coordinate, you're going to plug that into point slope form. And then lastly, in these problems, they specifically want this to be in slope-intercept form. So basically, y just got to be by itself. So after we have point slope form, we're just going to kind of move some stuff around, get y alone, and we'll be good to go. So in this problem to start, they're telling me that my line is parallel. I see in this equation, this is in slope-intercept form. My slope here is 6, So the parallel slope's also got to be 6. Now I'm going to plug in my coordinate and my slope in for point slope form. So I'll do y minus negative 3 equals 6 x minus 1. Lastly, I'm going to solve for y. So distribute this out. Get the 3 over, and I'm left with y equals 6x minus 9. And I'd be done. The last problem that I'm going to look at is they want a line perpendicular to y equals negative 4x plus 2 over 3 through the coordinate 8, 5. So here, similar to part A, all that I care about in this original equation is the slope. I don't care about the y-intercept necessarily. The only important information to me is my slope. The slope is negative 4. If the line is perpendicular, that means starting with negative 4, I'm going to flip it to be negative 1 over 4, and then I'm going to change the sign. So my slope is positive 1 over 4. Now, same thing, I'm going to plug it into point slope form. Y minus 5 is 1/4 x minus 8. Same steps, I'll distribute out and then bring the 5 over. And 5. So I'm left with the final equation. Y equals 1 over 4x plus 3.